Hello and welcome back. To begin our study of structural art, we need to go to Great Britain and study the works of Thomas Telford and also two other men named Stevenson and Burnell. I'm going to begin each lecture by defining some lecture goals. And in this lecture, the goals are 1. To show how the definition and ideals of structural art began, and as I mentioned, they begin in Great Britain. 2. Contrast the works of early iron bridges. And 3, we're going to do that contrasting by critiquing structures through what we call a comparative critical analysis. In these analyses, we critique both the technical and aesthetic aspects of the bridge design. So with these changes, from the scientific point of view, we have a new material that is born of the Industrial Revolution, iron. From the social point of view, we have a new opportunity, industrialization. And from the symbolic point of view, we have a new vision, a new form for structures, which we define as structural art. Let's start by comparing a pre-industrial revolution structure to a post-industrial revolution structure. One example of a pre-industrial revolution structure is Stonehenge, and I use this example of Stonehenge to show essentially how far stone can span. In Stonehenge, the unsupported length of that beam, that horizontal member, is on the order of 10 feet. Stone is not very strong in tension, and this beam on the bottom surface is experiencing tension. We're going to learn more about beams and tension in later lectures, but for now, know that, again, stone does not carry very large tensile forces. It's not strong in tension. In contrast, we have the iron bridge, the first bridge designed of iron, and iron is strong in both tension and compression. The iron bridge spans about 100 feet. Now 100 feet today is not very long, especially if we compare it to, for example, the Golden Gate Bridge at 4,200 feet. But back then it was a very long span. It was designed in 1779 by Abram Darby III. It wasn't intended to be designed as a long span bridge, but really it was intended to be an advertisement for his company. If you go to the bridge, which is still standing today, you'll see a plaque that says, quote, "It was intended to be an advertisement for the skill of the Coalbrookdale iron makers." The Darbys were in business for building pots, pans, and weapons, and they used the iron bridge as a visible advertisement to show how iron can span 100 feet between supports. Let's take a closer look at this new material, iron, that came following the Industrial Revolution. Iron is stronger than wood and stone. For example, in compression, iron is about 10 times stronger than stone, and in tension, it's on the order of magnitude of 100 times stronger than stone. Iron is also more permanent than wood, but not necessarily more permanent than stone because iron will corrode. And finally, iron permits forms that are lighter than those of stone. Because it is stronger, you need less material to build it. A closer look of the iron bridge, we see that it is comprised of 5 iron arches. It is, as I said, the first cast iron bridge, and it's very light compared to others of the time, and it's built of a way that's made to look like a wooden structure, essentially carpentry in iron. We see mortise and tendon connections, for example. Next, we're going to look at the social aspect of these British metal forms, but before we go there, I have a question for you. The density of cast iron is about 450 pounds per cubic foot, and the density of stone is about 150 pounds per cubic foot. So which of the following is true? 1. A cast iron bridge will be heavier than a stone bridge. 2. A stone bridge will be heavier than the cast iron bridge. Or 3. A stone bridge will be just as heavy as a cast iron bridge. The answer to the question is a stone bridge will be heavier than a cast iron bridge. Although cast iron is heavier than stone by volume, it's also much stronger than stone. Therefore, one can use much less material to build an arch. The resulting iron arch is much lighter than a stone arch. For example, for the bridge built by Rowland Burden Esquire over the River Wear at Sunderland, an iron arch was estimated to be 15 times lighter than a stone arch of similar size.